You've seen it in every good indie game. Now you'll learn how to do it. We will give game objects randomized animated skins, and we will make components talk to each other using C# events, the same modular, event-driven approach used in real production-level Unity games. This class is for complete beginners. If you know how to install Unity and create a new 2D blank project, you're more than ready. I'll show you exactly how I built this animation system using just 2 clean, modular, and reusable scripts. It's the same technique I use in my Tower Defense masterclass to give every pixel art creature a different animated skin. After this, you'll be ready to join me for one of the bigger, fully featured game projects. I'm in Unity 6, but it will work with any version. I have a blank Unity project, and down here in Assets, I create a new folder I call Art. I drag and drop the background image in here. I set sprite mode to single and drag it into the scene. Unity automatically creates a game object for it and gives it a sprite renderer component. I reset transform to center it. In game view, we want full HD, 1920 x 1080. I like to have my scene and game views visible at the same time, so I move it down here. I rename this to background, and I drop 4 whale sprite sheets into my art folder. With all 4 selected, I make sure sprite mode is set to multiple, and max size is 4096 to see the images at full quality. I apply that, and now slice them into individual frames. With whale 1 sprite sheet selected, I open the sprite editor. I go slice, grid by cell size. Frames are 420 x 300 pixels. Then slice and apply. Click the like if you want me to make more game development content like this. I do the same for the other 3 sprite sheets. Slice, grid by cell size, 420 x 300, slice, and apply. I expand one of the sprite sheets and drag any frame into the scene. With that new game object selected, I keep it on the default sorting layer, but I make sure it's always drawn in front of the background image by setting order in layer to 1. I rename it to whale. Let's animate it. Go to Window, Animation, Animation, and I'll dock the panel here. Inside Assets, I create a new folder called Animations. With the whale game object selected inside the animation panel, making sure it says to begin animating whale, I click Create. Inside Assets Animations, I create a new animation clip called Whale 1. I make sure I see it here in this dropdown, and I can see the clip file inside the Animations folder. If you want to practice what you've learned and explore even more, check out the links to my extended classes, where we build a complete, fully featured minigames from start to finish. My extended classes always include tons of free premium art assets, full source code, and are structured to guide you through the entire game development process from a blank Unity project to a fully playable version on multiple devices. Buying my classes is the best way to support my work, and thank you to everyone who's left a 5-star review. It really helps me reach more people and create more free content for everyone here on YouTube. Inside Assets Art, I expand Whale 1 sprite sheet. With the Whale 1 game object selected and Whale 1 animation clip active, I left-click the first frame, then shift-click the last frame, selecting all the frames in between. I drag them onto the timeline. I can play the animation here. This plays too fast. I can change animation speed here inside the samples field. If the field isn't visible, I can enable it from the drop-down by selecting Show Sample Rate. 25 frames per second seems like a good speed. So we have this whale game object, and I want to use all 4 of these sprite sheets to turn each one into a separate animation clip. Then we'll make this single whale play one of the 4 animations randomly, creating randomized animated skins. To create the second animation, I go here, create a new clip called Whale 2, expand the Whale 2 sprite sheet, left-click the first frame, shift-click the last frame, and drag and drop them onto the animation timeline. Set samples to 25 and play the animation to check all good. The second whale skin works. I repeat the same process for whale 3 and whale 4. If keyframe icons don't appear here, it means the main whale game object got deselected. But if I select it again, I can see the frames. 25 samples and play to check if it works. You can download the full source code and final Unity project for this class using the link below. It's a great way to compare your project with mine. It might help you with debugging, or if you're feeling a bit lazy and don't want to type out all the scripts yourself. Create a new clip. Left-click the first frame, shift-click the last frame, and drag and drop them onto the animation timeline. Now we have one whale game object and 4 animation clips associated with it, one for each separate skin. Unity also created an animator controller file. I can double-click it to open the animator window, or open it manually via Window, Animation, Animator. In Unity, the animation panel is where you create and edit keyframe animations, while the animator panel is where you can control and blend those animations using a state machine. If I enter play mode, whale 1 animation will be playing, but if I click whale 2 here and set it as the layer default state, it will play that animation instead. The way we'll set it up, we want to have multiple whale game objects, and each one will randomly choose one of these 4 animations, so each whale will look different. Let's write it as a small reusable script you can keep and use in other projects. It will be modular and easy to slot into all kinds of game projects you might work on later. Inside Assets, I create a folder called Scripts. Inside, I right-click, Create Monobehavior Script. If you don't see it at the top, it's down here under Scripting. I name it Choose Random Animator State. I double-click it to open it in my default code editor. Unity creates some boilerplate code with start and update lifecycle methods. We only need start this time, so I delete the rest. This script will need access to the animator component, so I create a private variable, type is animator, and I call it _animator, like this. Private means this variable can only be accessed inside this class. No other scripts can directly see or modify it. Animator is the type of the variable, in this case Unity's built-in animator component. C# understands the animator type in our code because we're using the Unity engine namespace up here. This is a variable name which can be anything. I follow a convention where private fields start with an underscore. It's not required. You can name your variables however you want. In Unity scripts, variables declared at the class level are called fields. Here, we created a private field that will hold a reference to an animator component attached to this game object. We will also need to hold an array of the 4 possible animation states we created. This line of code means we created a private array of strings named animation states, and we make it visible in the Unity inspector so we can assign values to it there. We'll get back to this in a minute. I save the changes to my script and go back to Unity. Whale game object selected here, and in the inspector panel, I drag this new script as a component onto the whale. It has the animation states array here. I can expand it and click the plus icon 4 times because we created 4 different animations. Each one of them will reference one of these animator states by name. I have to be careful with the spelling here. It needs to match exactly. Whale 1, Whale 2, Whale 3, and Whale 4. So in Unity, the serialize field attribute tells the engine that even though this field is private, it should still show up in the inspector. The type here is an array of strings. A string is simply a text value. I call it animation states. The spelling uses camel case, which is a common convention for serialized fields. We're inside this choose random animator state script. We have a field for the animator component, but we actually need to point that variable to the component by using the built-in getComponent method. This line gets the animator component attached to the same game object as this script and stores a reference to it in the animator field. From this point, we can control the animator component from this script and do all kinds of things, basically anything you want. Custom script components in Unity are incredibly powerful. Let me show you how to choose random animation from these 4 available animations we created. If there are no values in this array, meaning its length is 0, we return, which means we end the function and don't run the rest of the code. If there are some values in the array, the code will continue, and I create a temporary helper variable. The type is string, which is a text value, and I call it random animation. It will be one of these 4 values, so animation states array at index 0, 1, 2, or 3. If I want that to be randomized, I simply set the index to a random value between 0 and the length of the array, like this. Once we pick one of these 4 animations randomly, we take the animator component and call its built-in play method, passing it the animation we want to play. So when choose random animation runs, animator play will randomly play either whale 1, whale 2, whale 3, or whale 4. Save that, the animator is here, and it will randomly play one of these 4 animations. Back in my script, here we declare a function, but we actually have to call it from somewhere to run the code inside. In Unity, the start method runs once, automatically, when the script is first enabled. In practice, right now, it will run once when we enter play mode. After I point this variable toward the animator component, I call choose_random_animation, like this. Save that, and back in Unity, every time I enter play mode, this whale game object will get randomly assigned one of the 4 possible animations. I hope that makes sense. If you have any questions, let me know in the comments. We wrote our first very simple script and we are already doing some really cool stuff with it. To really see how the skins are randomized, it's better to have multiple whales on the screen at the same time. Inside Assets, I create a folder I call Prefabs. I drag this whale game object inside the Prefabs folder, turning it into a prefab. Notice that it turned blue here. We turned that single whale game object into a prefab. Prefabs are one of the Unity's core concepts. It's a saved template of a game object, basically a reusable blueprint. We can drag it into the scene as many times as we want to create identical copies of that game object. This warning message in the console can be ignored. All our animations will work, and you'll see that in a minute. You can see the prefab here has this little preview frame. We can easily change it to anything we want by dragging a different sprite into the sprite field on the sprite renderer component. With the prefab selected and its sprite renderer visible here, I go to the art folder and I drag, for example, this frame in. The little preview of the prefab will look like that now. When we play, it will be overridden by our animation logic, so it doesn't matter what we put here. Let's drag many whales out into the scene, like this. One more here, and one more here. Now, when I play, you can see how each whale randomly gets one of the 4 animator skins we created. We have a nice variety, and everything is animating at the same time. This is pretty cool, and we achieved this with just a few lines of code. Now that we know how to write simple scripts in Unity, let's write another one. What if I want these whales to endlessly move from left to right, and when they move off screen, they reset and travel across the screen again? Inside Assets Scripts, I create a new monobehavior script. I'll call it Move Across Screen. I go to Prefabs, and on the main whale prefab here, I make sure I do this on the main prefab, not on one of the copies. I click Add Component here, start typing Move Across Screen to find it, and I select it. So we can add custom script components by dragging and dropping them here, or by using the Add Component button. I can click the new script here to open it in my code editor. In this case, we'll need the start method that runs just once, and we will also need the update method that runs continuously. I'll declare fields for minimum and maximum horizontal position, and minimum and maximum vertical position. F means it's a floating point number. If you look at the Unity scene view, we have this grid. Each cell in the grid is 1 unit. Position 0, 0 is in the middle. So minimum position X is minus 15. That's 15 units to the left of center. And maximum position X is plus 15. So here. Minimum position Y is minus 4. It means we go down 4 units. And maximum position Y is plus 4. So up here. These values define the range of motion. We can tweak the numbers later. Each whale will also move at a randomized speed between min speed of 0.2 units per second and max speed of 2 units per second. I included the serialized field attribute on all these fields, which means that even though they're private, we can still edit their values in the Unity inspector. We will need a helper custom method I call setRandomPosition. This method will run only once, right at the beginning, to distribute the whales all around the screen within the horizontal and vertical constraints we defined. So random x, the horizontal position of the whale, will be a random value between min position x and max position x. Random y, the vertical position of the whale, will be a random value between min position y and max position y. To actually set the position of a game object, we access its transform position and set it to a new vector 2, where the horizontal component is this value and the vertical component is this value. A vector 2 is a value that stores 2 numbers, one for the x position and one for the y position. It's often used in Unity to represent 2D coordinates or directions. When the game first loads and the start method runs, that's when we want to run setRandomPosition to randomly place the whale somewhere in the game area. Save that, and back in Unity, I go to Assets Prefabs and select my whale prefab. I can see the Move Across Screen script component and all the fields we just defined are editable here. At this point, they become cached, so if I change one of the values here and I save it, it won't update. Whatever values are here are now cached. I need to update them here. The default values we defined in the script will only apply when I add this component to a new game object. So I'll change the horizontal constraints here like this, minus 10 horizontally and plus 10 horizontally. Vertically, we have minus 4 to plus 4. Now, when we enter play mode, whales will be randomly distributed within this area. Every time I enter play mode again, they'll be redistributed randomly. I make sure I exit play mode, go back to my script, and now I want the whales to float through space from position minus 10 to plus 10, then reset to minus 10 and float across the screen again, over and over. Back in my script, we'll focus on the code block inside the update method, which runs repeatedly once every frame. When we want to do anything to a game object's position, we access its transform position, and we use plus equals because we want to add something to that value every frame as the game runs. I want the whales to move from left to right, so I can simply use vector3.right, which is vector3, 1, 0, 0. Because this has a positive value of +1 for the horizontal x-coordinate, the object will move to the right. When we do any position updates here, we should account for the time passing by using time.deltaTime. The reason is that different devices have different performance and some can run the update method more frequently, meaning the whales would move faster on some devices and slower on others. If I want my game object to move at the same speed on any device, regardless of frame rate, I account for real time using time.deltaTime. This bases movement on elapsed time instead of frames. It's one of the fundamental principles of game development. We also have min speed and max speed here. We will need one more helper variable I'll call speed. Inside start, speed will be a random value between min speed and max speed. Now that we have a speed, we account for it in the movement calculation, like this. Each of our 4 whales will move at a different speed within the range we defined. Save that. And now, when I play, all my whales move to the right at randomized speeds. I exit play mode and go back to my script. As the whales move to the right, if the horizontal position of a whale is greater than or equal to max position x, we want to reset its position and maybe also randomize other things, like its visual skin or speed. Let's put that logic into a separate helper function I call reset position. Every time the whale moves all the way to the right, we will set it all the way to the left and randomize its vertical position again. So random y is a random range between min position y and max position y. When reset position runs, we set the transform position of the whale to a new vector 2, where the horizontal component is min position x. We'll set it to -10 for now, and the vertical component is random y. Back in update, as the whale moves to the right, when it moves past max position x, we call reset position. I save that, hit play, and I can see the whales floating across the screen and resetting to float again. Down here in game view, we have a simulator where we can test how our game behaves on specific devices or platforms without needing the actual device. I select Samsung Galaxy preset, and if I expand this, I can access the rotation controls. I want a landscape mobile phone, which is slightly wider than the standard 16:9 ratio screen. I want to make sure the whales reset well past the visible game area, so there are no visible jumps. With the whale prefab selected, on its move across screen component, I set the horizontal checkpoints to -15 and +15. I hit play to see if the whales are fully outside the visible landscape mobile screen when they reset. Yes, this looks great. As the whales move, they are all drawn on the same sorting layer, and Unity is deciding randomly which one is drawn behind and which one is in front. In games like this, we usually define a sorting rule for less flickering and more visual cohesion. Let's say I want to set a rule where objects that are lower on the screen are drawn in front of those that are higher. That means whales lower on the y-axis will appear in front, and whales higher up will appear behind them. Since I built this using the 2D universal render pipeline, I can go to Assets Settings, and I find the Renderer 2D data file. Here, under Transparency Sort Mode, I choose Custom Axis, and will sort objects along the vertical y-axis by setting it to 0, 1, 0. That means objects with a higher vertical y value are drawn first, behind the objects with a lower y value that are drawn afterward. Now, if I play, you can see that the draw order follows that rule. We have two custom scripts: choose random animator state, which randomly assigns each whale one of the 4 animations we created, and move across screen, which moves the whales around and resets them. What if I want every time the whale resets to use the other script to randomize the animation again? For that, we will need our 2 custom scripts to communicate with each other in some way. We could create a hard connection by directly linking them, but for bigger modular projects, there's a better way to do that. Let's learn an easy and super powerful technique. We'll make components fire events to signal that something important happened, and make other components subscribe to these events and run specific logic in response. This way, we are keeping our components fully separate and modular, while still allowing them to communicate. Knowing how to do this will allow you to build proper, fully featured, modular and scalable game projects. I go to the Move Across Screen script and define a public event. The type is action, and I'll call it, for example, onReset. To be able to use action, we need system namespace up here. This line means we are declaring an event that other scripts can subscribe to and respond to when it's triggered. After I included the system namespace, I get this issue with random range, because random is now ambiguous. There are 2 versions available: UnityEngine.random and System.random. Since we're including both of these namespaces, Unity doesn't know which one we want. Inside a Unity project, we always want random range coming from Unity Engine namespace, so I adjust this line of code like this. I do the same fix here, and also here. As we said, this line of code creates a signal called onReset that other scripts can listen to, and when this event is invoked, all subscribed methods will run. Now we have to choose when we want to activate this event to send that signal out. We want to do it here, whenever the reset position method runs. I write onReset ? .invoke like this. This line simply means if onReset event has at least 1 subscriber, if there's any scripts in our codebase listening for it, then invoke it. We can also randomize the speed of the whales again if we want. So every time we reset a whale's position, we're sending out a signal to our codebase that any of our scripts can subscribe to. Save that, and now I simply want to randomly assign each whale one of the 4 skins again, whenever the whale resets to its starting position. We will handle that logic inside the choose random animator state script. We will need a reference from this script to the other move across screen script. So I create a private move across screen, like this. Inside start method, I point it towards that component using getComponent. We did the same thing earlier with the animator component. Then, if there is a move across screen component available, we want to subscribe to its onReset event. We are invoking that event here and declaring it here. So if this component exists, we subscribe to its onReset event, and whenever onReset fires, we run the choose random animation method. That method will simply choose one of the 4 available animations at random and it will play it. This is the syntax we use to subscribe to events in Unity. We should also always unsubscribe from our events, because if this object gets destroyed while still subscribed to an event, Unity's garbage collector can't clean it up. That can lead to memory leaks or even null reference exception errors. But these are more advanced topics I'll cover in a different class. For now, just remember, we should always unsubscribe from events if we want to keep our code clean and production ready. Following these practices is how real full games are made, so let's build good habits from the start. I simply say, when this game object gets destroyed, unsubscribe. To create an event, we first define it as an action. Then choose where in our code to invoke it. We can react to the same event from multiple different scripts at the same time. It's very powerful. For example, here we subscribe to that event and define what code we want to run whenever it fires. And as we discussed, we always unsubscribe. If I save, enter play mode, and run the game, we have an endless herd of randomized space whales floating across the screen. Let's follow one of the whales just before it resets and see if the skin changes as well. Yes, it resets its horizontal position, randomizes its vertical position, and it gets a new random skin. Click the like if you want me to make more game development content like this.